Greetings, class. Several of you have been working in Chapter 5, Section 1. What I wanted to look at is rather than using the table values, which you were using to do your homework, where you had the standard normal distribution where the area was always to the left of the z-value, that we might go ahead and look and see how StatCrunch can work this same type of problem. And it's important to understand that for a standard normal distribution, the graph has a mean of 0 and a standard deviation of 1. So when you go to StatCrunch to calculate the area of the shaded region, you go to Stat, Calculator, and you need a normal distribution because this one's a standard normal, and once you click normal, then you have to check and see, is your mean 0 and is your standard deviation 1? In this particular curve from problem 5.1.18 of the study plan, you want the area to the left. Now, if you were on a number line and you were moving to the left, that would correspond to the inequality less than or equal to. And the z value that they have given you is 0.46. So if I click compute, you'll see that we have a red area very similar to the blue area, and the probability is 0.67724,189. StatCrunch usually keeps 8 digits. So if we want to round that to 4 decimal places, I would have 0. Now here are my decimal places, 6772, because the 4 that comes after the 2 is not going to be enough to round that 2 up. So let's just check our answer there and see. Now the next question wants to find the area to the right. Now if you were looking at the standard normal table with all of these z values, you would have to figure out what this same area would be equivalent to on the left side. But with StatCrunch, you still are using, I'm going to close this one so that we have that table, and then I'm going to open another one so that for each question you have a StatCrunch. So I'm going to go to Calculator, Normal. The mean is still 0, and the standard deviation is 1. This time I want the area to the right, which would correspond to the inequality greater than or equal to. And the value they've given me for z is 1.74. And so when I compute, I get a red area that looks much like the blue area in my stat lab or MSL. And the area of the shaded region to 4 decimal places, 0.409. And then this 2 to the right of that is not enough to make the 9 to go up. So we have 0.0409. For our area, so let's check that. So that's definitely a good question. We did good with that, did well with that question. Now the next one is a between. Again, with the standard normal table where you're looking to the left of z. Everything here, if we wanted to the left, we'd have to figure that whole area to the left and then subtract off this area right here. But with Minitab, let me close this one so we get ready for the next question. Stat, Calculator, still a normal calculator. The mean is 0, the standard deviation is 1, but this time I don't want it less than or greater than, I want it between two values. So you have to come over here and click the between, and I want it between 0 and 0.7. Those are the two values that were the two z values that were given to me in the table. When I click compute, I get a red area very much like the blue one, And it says the probability is 0.2580. So to 4 decimal places, 0.2580. So you've used, let's check that and make sure that's okay. So you've used the standard normal calculator to find areas to the left, to the right, and between. I'm going to pause for just a second and find some other problems that might be helpful. All right, I found another problem from the study plan, problem 5.1.35. This one's a little different because I want the area to the left of z equal negative 2.63 and to the right of z equals 2.63. Now, because the standard normal curve is symmetric, all I need to do is find one of them. If I find one of them, then I know the area for the other one is exactly the same. So, and I'll find both of them and show you that that is true. So let's start with stat, calculator, normal. Our mean is 0. It's very important. Standard normal curves, mean of 0, standard deviation of 1. And this time I'm going to start with left of z equal negative 2.63 would be less than or equal to negative 2.63. And I'm going to compute. And you see we have this very tiny area here, but it is to the left. Here's negative 2, there's negative 3, so that'd be about negative 2.5. So this looks like a negative 2.63. And note that the value, I'm just going to see if I can copy this and paste it in my table. But that was for the negative value. So I'm going to see if I can put this in my table here. And it's there. So that was the one for less than negative 2.63. Now let's go back and do the greater than, but this time a positive 2.63. And if you notice, it's on the other end, but it's basically the same size and shape of the one that you just completed. And its value is 0.004 26924. So I'm going to go back up here, right underneath that other one, and paste it. And you'll see that those areas are exactly the same. So that if I did 4 decimal places and added those together, that's actually, I've got to clear out that pink row. I don't know why it's pink. I clicked on something. But if I were to add those, this would be 0.0043. And also 0.0043. The symmetry of this normal curve allows us to add those. Or you could just double it if you wanted to multiply by 2. But if I added those, I would get 0.0086. So let's check that and see. Very good. We got that one correct. And I thought that I might look at this particular problem 5.1.47 from the study plan. In this one, it says find the indicated probability using the standard normal distribution, and it wants the probability that your z value is less than negative 0.32. And so what you need to understand is that when we've been looking at the area under the curve, where the entire area is 1, it sums up to a value of 1, that we've essentially been looking at probabilities. So if I wanted to define this particular probability, all I would need to do is go back to stat, calculator, and normal, be sure that my mean is 0, and that my standard deviation is 1, and then I'm going to pick, instead of, I know it says X, but we're looking at Z value, and I have to choose less than or equal to. I don't have a less than. But since these are continuous, then the less than works perfectly well. So I'm going to compute, and so you can see that 0 is here, -1 is there. And think of these as z values because it's when mean is 0 and standard deviation is 1, we're talking about values for z. But the probability is the same as the area under the curve, which in this case would be 0.37448, which that 8 would make the second 4 become a 5. So that would be 0.3745. Let's check that and see how we did. Excellent. And so anytime it's asking you to find a probability, I'm going to close this so that's captured in the session. Then you just go back to Stat, Calculator, Normal, verify that you have a mean of 0 and a standard deviation of 1. That's what you need to find z values. This one wants greater than. My only option in the calculator is greater than or equal to, but again, perfectly fine because this is a continuous distribution, not a discrete. So -0.29, we want our value to be greater than -0.29, and the probability is 0.6140, but the 9 that comes after the 0 makes the 0 a 1 when we're rounding. So that would be 0.6141. We'll check that answer to make sure we're okay. So these are all about probabilities. And this one would be a between because you've got a z value between two numbers. So I'm going to close this one, and then I'm going to do calculators, normal, again, a mean of 0, a standard deviation of 1, and I want a between. So, but my two values for the between are -2.28, -2.28, and then on the right I want a 0, and I just click compute, and the area is 0.4886, and then the 9 makes that 6 become a 7 since we're rounding to 4 decimal places, so that's 0.4887. Let's check and see how that works. Excellent. And so that will end up our information about Chapter 5, Section 1. I'll do a separate video for Section 2. Thank you for your time. I hope you find this video helpful.